It's difficult to imagine how it felt to print a document for the first time. I'm not referring to an inkjet printer or a laser printer. I'm talking about when the first ever printing press was invented in around 1440. The concept of making an identical copy of something was completely radical, and it took decades and even centuries for the world to appreciate the full potential of Gutenberg's press. But once they did, knowledge could be bagged up and shared at unprecedented scale. No more Chinese whispers, no more spending days, weeks and years writing out scrolls by hand. Finally, we had the catalyst for countless advancements in language, culture and industry. The comparison to printing's next giant leap isn't there yet, as 3D printing is still in its infancy. But it is on track to make an even bigger dent than Gutenberg's press did in society, industry and our evolution. Although we've been printing in 3D for over 30 years, in the past several years it's been completely democratised. In the 80s, 3D printing was reserved for big enterprise, with machines costing hundreds of thousands of dollars. Now you can walk into Kmart and buy a 3D printer for $200. Although it appears completely science fiction, the way 3D printing works is remarkably simple. It's a series of 2D prints, layered on top of each other, stack after stack, ultimately forming one large object in 3D. The impact of this technology is filtering through our lives very slowly, but with statements like this from Obama from a couple of years ago, it's an area of innovation the world is definitely paying attention to.
There are things we can do right now to accelerate this trend. Last year, we created our first Manufacturing Innovation Institute in Youngstown, Ohio. A once shuttered warehouse is now a state-of-the-art lab where new workers are mastering the 3D printing that has the potential to revolutionize the way we make almost everything. There's no reason this can't happen in other towns. So tonight, I'm announcing the launch of 3 more of these manufacturing hubs, where businesses will partner with the Department of Defense and Energy to turn regions left behind by globalization into global centers of high-tech jobs. And I ask this Congress to help create a network of 15 of these hubs and guarantee that the next revolution in manufacturing is made right here in America. We can get that done.
Manufacturing is the most immediate and obvious industry to be affected. Usually production of something physical has been produced in giant factories and the courier company needing to deliver it. Now with 3D printing, we can bypass both of these phases and produce hardware in our living rooms. Removing these industrial legacies has massive implications for logistics companies, as we don't need to send physical objects anymore. The only thing we need to send is a digital file, which can happen instantly and at no cost. The most popular material to print with is plastic, which comes in a reel that's fed into the machine and squirted out by a small needle. But over the past few years, the machines have evolved, allowing us to print with over 300 different materials, ranging from titanium to chocolate. This episode, we look at the coolest innovations that are driven by 3D printing technology, and what it will look like when it begins to reach its potential in the next decade. This is Future Sandwich, Episode 7, 3D Printing the Future. The first material that you wouldn't expect to come out of a printer is food. Here's a clip from The New Yorker, where they interviewed a food scientist who's experimenting with making delicate little prints of food to complement our Michelin-starred dishes.
Everybody's out to amplify their sensory experience. The only way to stay ahead in an industry as competitive as restaurants is to innovate beyond your competitors. This could be an avenue in which a chef could put themselves ahead. So this pumpkin that you see here was filled with a pumpkin caramel ganache, garnished with a little bit of mint, and served as a truffle. If it can be molded by hand, we wouldn't print it. Otherwise, there's no point in the machine. I have a tool right here that pulls up spikes. I have a hot wax simulator tool. This is a cursor that gives me 360 range of motion. I can draw whatever shape that I want to cut. Once I import the model into a software called ZPrint, this software speaks directly to the printer. And it just sent it. The printers we're actually using were originally built to print plastic and polymer powders. We tamp it with a 50-50 1-to-1 ratio of 6x confectioner's sugar and Star Dry 5 maltodextrin. We've added things like maple, cinnamon, cardamom, guava. So this is a model of a quail eggshell that's printed out of a wasabi-based powder. Through an HP printhead, the same kind of printhead you find in a paper printer, it just begins to paint. So when you think about it, the printer itself isn't actually a 3-dimensional printer. It prints hundreds of thousands of times in two-dimensional cross-section layers that build upwards to create the hyper-defined models that you see. So as the model builds up, the tray lowers, and now it's my responsibility to find them and excavate them like an archaeologist would a dig, guiding chefs to understand that the purpose of this is not to replace them with a machine. That's been the biggest struggle so far. We're not trying to replace craftsmanship. What we want to do is educate people as to the possibilities, as well as a way to think. Our printers were not originally designed to do what we're using them for. That thought process came from the collaboration between an architect and a food-centric mind. So a real important thing here, whether that be in engineering, architecture, food, construction, is that you could learn so much from everybody around you, and you can utilize their knowledge in conjunction with yours to create something new, something exciting, and something fun.
The world of fashion is all about experimentation with materials. Technology has seen the fashion industry go into weird and wonderful spaces. With Google's Project Jacquard, it's weaving tech into the fabric, allowing you to swipe your sleeve which talks to your smartphone. And Claire Danes recently wore a dress made of 1,000 LED lights that lit up when people mentioned her on Instagram. But 3D printing has the potential to do more than be an outlet for creativity. It has the potential to remove the need to even go to a store in the first place. This is fashion designer Denise Peleg in her recent TED Talk.
In the past few months, I've been traveling for weeks at a time with only one suitcase of clothes. One day I was invited to an important event and I wanted to wear something special and new for it. So I looked through my suitcase and I couldn't find anything to wear. I was lucky to be at a technology conference at that day and I had access to 3D printers. So I quickly designed a skirt on my computer and I loaded the file on the printers, just printing the pieces overnight. The next morning I just took all the pieces, assembled it together in my hotel room, and this is actually the skirt that I'm wearing right now. And then I thought, if I can print a necklace from home, why not print my clothes from home too? I really like the idea that I wouldn't have to go to the market and pick fabrics as someone else chose to sell. I could just design them and print them directly from home. The breakthrough came when I was introduced to Filaflex, which is a new kind of filament. It's strong, yet very flexible. And with it, I was able to print the first garment, the red jacket, that had the word liberté, freedom in French, embedded into it. I chose this word because I felt so empowered and free when I could just design a garment for my home and then print it by myself. And actually, you can easily download this jacket and easily change the word to something else. For example, your name or your sweetheart's name.
Next, we hear from architect Alistair Parvin and his TED Talk that shows how the impact of being able to print your house has bigger implications than we think.
What these technologies are doing is radically lowering the thresholds of time and cost and skill. They're challenging the idea that if you want something to be affordable, it's got to be one size fits all. And they're distributing massively really complex manufacturing capabilities. We're moving into this future where the factory is everywhere. And increasingly that means that the design team is everyone. That really is an industrial revolution. When we think that, the major ideological conflicts that we inherited were all based around this question of who should control the means of production. And these technologies are coming back with the solution, actually, maybe no one. All of us. And we were fascinated by what that might mean for architecture. So about a year and a half ago, we started working on a project called WikiHouse. And WikiHouse is an open source construction system. And the idea is to make it possible for anyone to go online, access a freely shared library of 3D models, which they can download and adapt in, at the moment, SketchUp, because it's free and it's easy to use. And almost at the click of a switch, they can generate a set of cutting files, which allow them, in effect, to print out the parts from a house using a CNC machine and a standard sheet material like plywood. And the parts are all numbered. And basically what you end up with is a really big IKEA kit. And it goes together without any bolts. It uses wedge and peg connections. And even the mallets to make it can be provided on the cutting sheets as well. And a team of about 2 or 3 people working together can build this. They don't need any traditional construction skills. They don't need a huge array of power tools or anything like that. And they can build a small house of about this size in about a day. And what you end up with is just the basic chassis of a house, onto which you can then apply systems like windows and cladding and insulation and services based on what's cheap and what's available. Of course, the house is never finished. We're shifting our heads here, so the house is not a finished product. With the CNC machine, you can make new parts for it over its life, or even use it to make the house next door. So we can begin to see the seed of a completely open source, citizen-led urban development model, potentially. We shared the whole of WikiHouse under Creative Commons license, and now what's just beginning to happen is that groups around the world are beginning to take it and use it and hack it and tinker with it, and it's amazing. We're aware that WikiHouse is a very, very small answer, but it's a small answer to a really, really big question, which is that globally right now, the fastest growing cities are not skyscraper cities. They're self-made cities in one form or another. If we're talking about, the 21st century city, these are the guys who are going to be making it. Like it or not, welcome to the world's biggest design team. So if we're serious about problems like climate change, urbanization, and health, actually, our existing development models aren't going to do it. As I think Robert Newworth said, there isn't a bank or a corporation or a government or an NGO who's going to be able to do it if we treat citizens only as consumers. How extraordinary would it be, though, if collectively we were to develop solutions not just to the problem of structure that we've been working on, but to infrastructure problems like solar-powered air conditioning, off-grid energy, off-grid sanitation, low-cost, open-source, high-performance solutions that anyone can very, very easily make, and to put them all into a commons where they're owned by everyone and they're accessible by everyone. A kind of Wikipedia for stuff. And once something's in the commons, it will always be there. How much would that change the rules? And I think the technology's on our side. If design's great project in the 20th century was the democratization of consumption, that was Henry Ford, Levittown, Coca-Cola, IKEA, I think design's great project in the 21st century is the democratization of production. And when it comes to architecture and cities, that really matters. Thank you very much.
So when we can personally design and print our homes, suburbs and cities, our society will morph into a very different place. When 3D printing realises its potential, we will start to see some major concepts that society has lived with disappear. In terms of manufacturing, a concept that will be very new is the notion of complexity is free. Millions of colours and hundreds of materials mean we can make very complex things. For example, with our current 3D printing technology, we could print a toy car, including little rubber tyres, metal frame and plastic windshield, all in one print. Give this a few more years and we can feasibly print an entire computer with sensors, circuit boards and screens. Peter Diamandis, a leading investor, entrepreneur and Future Sandwich regular, recently did a blog post on 3D printing, which inspired this episode. You can see the links in the show notes at futuresandwich.com. One venture he champions is the Google Lunar X Prize, which incentivises entrepreneurs to colonise the moon. This is a video where he talks of the ability to print incredibly complex objects made up of multiple parts and materials on the moon.
So here's a fun question. If you or I were stranded on the moon with an advanced 3D printer, one that could print with any materials, but you had to in advance sort of set up the files and the raw material to bring with you to 3D print, what would you bring in 3D print? So the fact of the matter is today's 3D printers can 3D print in 300 different materials, right? You can 3D print in foods like chocolate. You can 3D print in titanium, in glass, and plastics, and rubbers, even the newest 3D printers in cloth. So if I had nothing, I'd probably want to bring a set of different clothes. I'd want to bring a set of different foods I could 3D print. I'd want to probably make sure I could 3D print a communication system in case my communications broke down. Ultimately, you want to 3D print the ability to have an oxygen generator that can take the oxygen out of the lunar regolith and generate a breathing environment. Heck, if we're going that far, I'd want to be able to 3D print a rocket with enough escape velocity to take me off the moon back to Earth orbit where I can be swooped up. I mean, those are the fundamentals. It's a little bit about luxury on the clothing and foods, and a lot about backup systems to back you up in case stuff goes to hell in the lunar handbasket.
This is where the concept of complexity to be free comes in. When you go to manufacture something, the more complex it is, the more expensive it gets. You want to build one part, let's say that costs $100. If you want to build 1,000 moving parts in one production run, that's going to cost you millions of dollars. If you want to change anything, even by a fraction of a percent, you have to go right back to the start. But for a 3D printer, it doesn't care if it prints a jet engine or a solid block of steel. It just reads the data and prints. One print is one cost. Therefore, complexity is free. It doesn't matter how much more complex the print is, it will always cost the same amount of time and money. You may have seen that odd photo of a mouse with a human ear growing off it. Well, that ear was essentially printed onto the mouse's back. It wasn't done using a hacked inkjet printer, but a much more sophisticated one that can actually print living cells that can form almost any human tissue, including everything from muscles to organs.
Imagine this, a technology that could bring an end to organ transplant waiting lists and, of course, the agony of losing a loved one who is on one of those lists.
It's a remarkable thought, isn't it? Well, U.S. researchers say they're getting closer to making that a reality. They say they've developed a 3D printer that can literally print cartilage, bones, and muscles.
This report from CNN talks with Anthony Atala, who is pioneering the research to 3D print pieces of ourselves.
You know, right now we've actually shown that we can print a broad range of tissues, from soft tissues such as muscle to medium strength tissues such as cartilage, which are elastic, to strong tissues such as bone. So the concept now is to keep testing these tissues so we can get them into patients. So
can you kind of go into the logistics of this and how you can actually 3D print living body parts? I understand you use living cells and kind of mesh that with some kind of gel.
Yeah, so the concept actually is if a patient has a defect or an injury, you can do an X-ray of that area, and then basically the X-ray shows the area of the defect, and we can download that information digitally into our software program that drives the print hits and actually will print a structure that will fit that patient using the patient's own cells. In terms of complexity, flat structures are the least complex, like skin. They're all complex, but flat structures like skin are the least complex. Tubular structures like blood vessels are the second level of complexity. Hollow non-tubular organs like the bladder or the stomach are the third level of complexity, and by far the most complex are the solid organs like the heart or the lung. And we're going to follow that pattern in terms of getting these tissues into patients.
So now when 3D printing comes up in conversation at a dinner party, you know it is much bigger than printing an action figure made out of plastic. It has the potential to, and will slowly over time, start making massive changes to how we work, live, and adapt into the next industrial revolution. Because we need to change how we look at stuff and start seeing that physical objects is just data. Every chair, car, necklace, and jet engine has the potential to be digitised and distributed and produced instantly anywhere. And the more you think about it, the bigger the impact of 3D printing gets. This has been Future Sandwich, Episode 7, 3D Printing the Future. Got lots of people to thank today. Let's start with The New Yorker for their profile on the food scientists. We got the snippet from a nice film you can find in the show notes. Thanks to designer Danit Peleg for the pieces from her TED Talk. You can see more of her at danitpeleg.com. The link is in the show notes also. Alistair Parvin's TED Talk on the impact 3D printing will have on architecture and how we will live can also be found on the show notes. And big thanks to CNN for their talk with Anthony Atala. And most importantly, Maddie Thompson for editing this like a boss. If you enjoyed the show, please subscribe to Future Sandwich on iTunes or follow on SoundCloud. Or get new episodes in your inbox by signing up at futuresandwich.com. Also, give me a shout on Twitter, @TMcCubbin. I'm always up for hearing what you think or any suggestions of people I should talk to. People who are making the future happen today. And that's a wrap for episode 7, 3D Printing the Future. We'll see you next time.